Hi you guys, welcome to lesson 4, simplifying rational expressions by factoring. So to start this, let's talk about what a rational expression is. So a rational expression is the division. So you want to be taking notes. So go ahead and write what I'm writing. Page numbers are numbered at the bottom if that's helping you. Is the division of two polynomials. So this could be like 2x divided by 7, 3x plus 4 divided by x squared plus 2x minus 7. Anytime we have a polynomial over polynomial, that is considered a rational expression. So the first thing we're going to talk about is just evaluating rational functions. So this is an example of what a rational function can look like. It's the h function. This is asking us to evaluate it at h equals 4. So everywhere I see a 4 or an x, I'm going to write a negative 4. So it's asking us to evaluate it at negative 4. Okay, you can go ahead and put this into a calculator or do it by hand. You'll end up getting negative 27 divided by 7. It asks us to simplify that as much as possible. We cannot simplify that any further. I want you guys to pause your screen and do h of 2 on your own. So you're evaluating this h function at h of 2 on your own. So go ahead and pause and evaluate h of 2. Okay, so you guys should have put in a 2 everywhere you saw an x. This should have a subtraction sign. Sorry, negative 35 over negative 5 equals 7. So we're going to move on to the next slide. Simplifying monomial fractions means that we simplify, monomial means one term on top and one term on bottom. So this is kind of back to our exponent skills that you guys learned. We're going to do this one together. You guys will do the first one on your own. So the way I think of it is I think of my constants, my x's, my y's, and my z's. You can write things out if you want to. So I have 2 x's on top, 1 x on the bottom, 3 y's, so I'm just going to go ahead and do my variables first, and then I can see what cancels out. So one of my x's cancel out, 3 y's cancel out, one of my z's going to cancel out with one of my z's down there, and then I end up with 1 x left on top, 3 y's left on top, and I have 8 z's on the bottom. And then I can think of 32 and 10. I can divide both those, divide by 2, divide by 2. So that'll get me 5 over 16, and I cannot simplify that further. Oh no. Okay, so once you have this, go ahead and pause. Now I want you guys to try this one on your own. So go ahead and pause and do this one on your own. Okay, so what we should have gotten is 8 x's left on the top, and we cannot simplify 7 over 2, so this is what we'd have. So remember, you should be taking these notes, writing these examples down. You can title everything by the slide number or the thing it says at the top. So now it's the same idea of just how we cross off x's and y's that matched up. We can cross off whole fractions that match up. So we can simplify, meaning to get it to its simplest form. That's like saying an x over x simplifies to 1. So x plus 8 over x plus 8 simplifies to 1. 2x minus 5 over 2x minus 5 simplifies to 1. So then we have 42 over 7. If I divide both those by 7, this equals 6 over 1, or just 6. So I'm going to go ahead and get you guys started on this one. I would think, and then you guys are going to do it on your own. I would think of this as like a 30 over 35. What would that simplify to? I had, this is what my y's are like. If it helps you to write each of these out however many times you need to, go ahead and do that. So I want you guys to think about how many of these can cross out, how many y's can be crossed out, how many would be left with at the top, how many y plus 4's would you be able to simplify, and how many would be left, and so on. So go ahead and pause your screen and try that. I'll show the answer here. So if it helps you could have written all these off and crossed out what you can simplify to 1, but this should be the answer you got here. 5y times 3y plus 5 divided by 6y plus 4. So we're going to go ahead and go to the next slide. So if you guys remember, when we divide, we cannot divide by a 0. So for example, if I gave you like 2 divided by 0 is undefined. So excluded values are values that cause us to divide by 0. So when we start looking at these, we're going to start looking at their excluded values. So we set the denominators of the we set the factors of the denominator equal to 0 and then solve for the variable. So if we remember, 0 divided by 2 is 0. So our top can equal 0, but our denominator cannot equal 0. So if I gave us like 3 plus 4 divided by x, when I solve this, 3x plus 4 divided by x, when I solve this, x cannot equal 0 because it would cause us to divide by 0. If I gave you something like x plus 3 minus x, our bottom cannot equal 0. So if I solve for x, x cannot equal 3. So we're going to work on problems like this now. Okay, we're going to do this first one together. You guys can do the second one on your own. So it says find the excluded values. If there's more than one value, separate them with commas. So we know that this denominator cannot equal 0 because it will be undefined. So I'm going to say 2y plus 10 cannot equal 0. So that so I do not know how Alex will ask you to enter it. So the excluded value is y equals -5, but y cannot equal -5. So depending on how it asks you to enter it, go ahead and think about that. If there's more than one value, separate them by comma. So go ahead and do this bottom one. You'd want to set each of these factors equal to 0. And those are the values that x cannot equal. So go ahead and pause the screen and select. So you should have gotten, depending on how Alex wants you to enter, either x equals -8 and 5/2 or x cannot equal -8 and 5/2. If we plugged in a -8, and if we plugged in a 5/2 into this, it causes us to divide by 0. So the excluded values are -8 and 5/2. So we're going to go on to the next idea of simplifying ratios with using a GCF. So if you need to take this note, remember GCF means greatest common factor. So that means I'm trying to pull out what they all have in common. So I'm going to do the second one first. You guys are going to do the first one on your own. If I look at my numerator, I see that they all have a 5 and that they all have a y. So when I pull out a 5y, I'm left with a 2y minus 5. I see that these also have a 5y in common, and I'm left with a y minus 8. So once I pull out a greatest common factor, I can look and see what I can simplify out. 5 divided by 5 is 1, y divided by y is 1. So I end up with this simplifying to 2y minus 5 over y minus 8. I want you guys to try this with the first one, so pause your screen, do this with the first one, and then I'll show you the answer. You could factor a 4 out of the numerator and a 5 out of the denominator, and then we could 3w plus 4 divided by 3w plus 4 is 1, so this should actually be, I just miscopied this. This is 4 over 5. That's my bad. Okay, this next idea we're going to talk about is simplifying a ratio to either 1, -1, or no simplification. So let's think about the first one. And I want you to think, is there any way that I can divide, does 2w plus 5 divided by 5w, or 5u plus 2 simplify to anything? I see that they both have a 5, they both have a 2, and they both have a u, but there's no way to rearrange this so that it can be simplified further. So this would say it cannot be simplified. If we look at this one, I have a 1u, a 1u, a -6, a -6. So I'm going to see what it would maybe look like if I rearranged this or wrote this in any way. Actually, like that is u minus 6 over u minus 6. Now these are the same things, and I can simplify this, so like this would simplify to a 1. If something gave you like if you saw something like this, what you could do is pull a negative out of the bottom or the top, wherever it is. So these are really similar, it's just all the signs are opposite. And this would simplify to a -1. So these are examples of what it would look like if you simplify, if it's undefined, and or not undefined, if it can't be simplified, if you simplify it to 1, or if you simplify it to -1. So we're going to go ahead and talk about, we've been dealing with either things that are already factored or once we factor are given to us linear. So we're going to start talking about what it looks like to simplify quadratic rational expressions. So the first thing we want to do when we look at these is we need to factor it. So part of your bell workstation you have to do is factoring. When you factor in, you want to look at the greatest common factor. That's the first thing you do. And then from here, you do one of these steps. Your bell work should spend some time going over this, so refer back to that if you're confused as we factor. Okay, so I have this problem here. I cannot simplify my denominator anymore because it is already a linear expression, but I can simplify my numerator. So here's my a, b, and c, so I'm going to do an ACB tree. So I need two numbers that multiply to 56 but add to my b of 15. I see that 8 and 7 multiply to 56 but add to 58. So I do v squared plus 15 or plus 8v. I can pull a v out of these. This is the factor by grouping now. And then these are my like terms, and then I have my leftovers. So I can pull out a v plus 8. I see that those simplify to 1. And this whole thing simplifies to v plus 7. So we're going to have another video to go through the last few slides.